Hey, thanks. Is the microphone good? Yep, cool. All right, so I'll just start with a quick introduction about what these technologies are that I'll talk about a little bit about. But actually, most of the talk will be much more general. It's ended up being a bit more of an opinion piece, which I actually often find more useful and interesting than talks about, the fine-grained details of some library. For the last few years, I've been developing this open source library, spaCy, and this really sprung out of the need that I saw for a library that took the types of results which were rapidly being generated in academia and that I was working on at the time and made them more accessible for industry. And then since soon after we launched that, I ended up co-founding a company with Ines Montani called Explosion AI. So in addition to the library spaCy, we have a machine learning library that we use with it called Think, and an annotation tool, Prodigy. And soon enough, we'll have a data store of pre-trained models that we'll be providing alongside spaCy as well. So as a sort of quick bio, this is I'm Matthew, and that's my co-founder Ines, and we're basically, together pretty much all of Explosion AI. So we're a very small company based here in Berlin that really just does commercial open source software. So there's the open source library, and then this commercial tool on top, the annotation tool Prodigy. So the way that we often explain the sort of structure of these things, and I guess we do this in Explain It Like I'm 5, or often explain it like I'm senior management. The analogy that we use is like a boutique kitchen. So the free recipes is kind of like the open source software. And then we started off doing consulting to support ourselves. But then we've since switched over to this sort of line of gadgets, which is this thing Prodigy and other extensions as well. And soon we'll have premium ingredients that we're selling with this. Okay, so to move into the talk proper, I'll start with this assertion. So the assertion here is that natural language processing projects are like startups, so they fail a lot. And so this is presented without, I'm not going to pretend scientific and give you like some survey or something, but we have seen this. And to give you a bit of an intuition for why this should be true, or to make it seem a little bit more obvious to you, imagine what the world would look like if NLP projects were not failing regularly. Because human language is basically the world's information system, this really underpins a lot of commercial activity all over the place, right? And so if it were true that these things didn't fail often, if it were true that we could easily automate a lot of the work that happens in back offices and that sort of underpins this economic activity, we would be seeing a far, far greater upswell in growth of the natural language processing projects. And instead, we do see plenty of growth in NLP as we do with other AI technologies, but it's nothing like what we would see if this were actually just easy and if everything just worked out of the box. So, and additionally, if you use these technologies like Translate or interactive chat applications or search or summarization things, you'll see that these technologies are far from perfect. And so there's this little dance that needs to be done to map those imperfections and get those imperfect technologies delivering useful enough value that justifies a commercial investment. And when this works, it works fantastically well. And so there's some projects which basically return the fund, like they say for startups, where a few projects are wildly successful, but then there's still a lot of failures. So now the question is, what drives that frequency of failure, and how can we avoid it, and how can we do better? And in particular, how can we make sure that your project isn't one of the ones that fail? Well, okay, so to consider this, we can flip the question on its head and say, all right, what would it look like if we wanted to maximize the project's risk of failure? Well, so I outlined some steps here. So step one would be, really just sit down and imagine here. So decide what you think your application ought to do, and, don't really fuss too much about what seems practical or what seems likely to work. Just, nobody changed the world saying, I'm not sure that that's going to work. So, that's step one, and then feed that step one forward into a forecasting process. So, given what you think you want your application to do, figure out what accuracy you'll need to achieve your dreams, and if you're not sure, just say 90%. Then, the next step of our, recipe for failure would be, well, okay, now we're just going to outsource this. So, we've thought carefully about what accuracy we want, and then, fortunately, we can use that estimate to somehow figure out how much data we want, except we kind of can't, so let's just ask for 10,000 rows or something. That should do. And then finally, this is the good part, the part which we all think about a lot for machine learning projects. It's time to wire everything up, time to implement the model, time to iterate and fit the model and do all of this good stuff. So this is the part which we all look forward to, and the part that really, when people talk about machine learning projects, this is the phase where the story starts for most people. And then finally, okay, hopefully we can integrate the thing into the project, and if it doesn't work, then I hope that we have some foreperson who we can blame. An intern might be a good target. Okay, so less cartoonishly, how does this actually look? Like, what's gone wrong here? Well, and in particular, I don't want to have this narrative that life is hard, failure happens often, life is uncertain, we should just accept it. I do think that there's a lot that we can do to minimize this, and so how can we do better? Well, we can start by thinking more broadly about what makes a successful machine learning application. And so here I've sort of outlined a little hierarchy of needs. And at the base of the pyramid, the sort of thing that you need most, the sort of basic comfort and security thing, or physical needs, is understanding how the model will work in the larger application or the business process. Basically this is the planning out of what the model will do and what need we're trying to get met for it. And that design question of what problem we're going to solve with machine learning is really the fundamental thing. And if we can have clarity about that, then we can often find ways to design the problems so that the problems will be easier to solve from the machine learning perspective. So we can make our lives easier and make sure that we're getting technologies that it will be we're crafting the problem in a way that the technology can easily meet. So then the next step is to take that business need and map it into annotation schemes and corpus constructions so that we can decide what the data should look like to actually meet that, to meet the needs that we have. And in particular, we want to make sure that we're designing the annotation scheme in a way that facilitates consistent annotations and easy decisions from the models. And this is actually a lot harder than it sounds, especially for natural language processing, because you end up kind of trying to divide the world into this ontology, right? And the world doesn't actually obey these fixed, neat categories. And so there's tends to be quite an art to actually coming up with annotation schemes and refining them over time that helps the data be consistently annotated, and it helps the model actually do what you want it to do. And then in addition, as well as actually the annotation scheme, there's an implementation phase of the annotation of, sort of running the project effectively so that your annotators know what they're doing, so that they're sort of reliably and consistently incentivized to give you the sort of annotations that you want, and that you've got a good feedback loop through this, and also quality control processes. So all of these things define what the problem you're going to be solving and what data you're going to use to solve and evaluate it. And then finally, on top of that, that's when we get to this sort of fun bit of, tensoring your flows and descending your gradients, of, deciding your model architectures and things. And then finally, the optimization as well. And so the model architecture and optimization parts, which, the academic community and a lot of the tutorials are focusing on. And this does make sense because, in a sense, it is kind of a limiting factor that, if as a global community we had better solutions to these things, overall projects would do better. But in any specific project that you're working with, it's very often the case that these aren't the things that are going to define success or failure. It's very often the earlier phases of this that are going to take your project from something that sort of works to something that really doesn't. So the problem here is that we end up with this chicken and egg problem. So in order to sort of figure out the product vision that we want, we really often need to know how accurate the model is likely to be on that problem. So there's a real characteristic difference that we'll have in the way that we design our application if we imagine that the model will be, say, 95% accurate versus if it's only going to be 80% accurate. And those assumptions and differences are we really want to bake that back into the way that the whole interaction flow is designed. For instance, a chat application is probably not going to work very well at all if we're making an error on every utterance. And the user has to constantly ask for clarification. If that's going to be the case, then we probably want to design our application differently. Similarly for translation, if the translation in our language pair is going to be pretty bad, then we hope that we could have a lot of dictionary backoffs and lots of like ways that we can click on words to like, help the user puzzle out what's gone wrong or what to do if the translation is bad. And so all these things about product design really depend on the accuracy estimate. And the problem there is that in order to get that sort of reasonable accuracy estimate, we have to start making contact with the data. We can't really pluck this out of thin air. And so we need to like start running some experiments. We need to start doing some training and evaluation. And in order to do that, we need to know what labeled data to collect. And in order to do that, we need to know how our annotations should look. But we don't really know how our annotations should look if we don't know what the model is supposed to do, which feeds back into the product vision. So we have this this chicken and egg problem of like what bit to solve first in this. And I think that actually drives a lot of the problem here. But okay, so the solution here is that we need to iterate on the whole process. We need to iterate on the code that we're developing for this and the model architecture and the optimization, but we also need to iterate on the data that we're developing and the way that we're framing the problems. So, as we said, like basically don't make assumptions, iterate at a more fine-grained level and sort of start going over the feedback loop more quickly. We have to figure out what models we should train to meet the business needs, and then we have to be asking, does the annotation scheme make sense when we start implementing it? Once we're doing that, we can figure out, does the problem look easy or hard? And then we can start moving back to the business case and saying, what can we do in the application to improve the fault tolerance? So to figure out why this is wrong or where this, basically, let's start to look at where this might go wrong. I think that this is actually probably the most interesting case of failure that I think we've observed while running spaCy and Prodigy and doing our consulting projects. And I think it's one which isn't often discussed. When I say modeling decisions here, I really mean the way that business requirements are mapped into a set of statistical models. So, we're going to have some statistical model or combination of models that are going to be predicting things. And if we start off with a sort of need of output, there's often a wide variety of ways that we can break that down into decisions. So here imagine that we want to build a crime database, and we're going to be feeding it news reports, and we want to extract the following information. So we want to label things like victim name, the name of a perpetrator if it's mentioned, a crime location if it's mentioned, the date of the offence, date of arrest if it's mentioned, all of this sort of information. So this is what we want output. That's what we want the sort of system to do. So how should we break that need down into one or more machine learning models? What data should we annotate to train them? How should we evaluate them, et cetera, et cetera? So this is what I mean by modeling decisions. And the claim that I'm making here is actually that these decisions are incredibly important and really drive success or failure, much more than decisions about using an LSTM versus using a CNN or something like that. Okay, so here's one obvious way to do it that I'm going to suggest is probably pretty unideal. Imagine that we're going to be labeling these as, basically spans of text as victim and another span of text as crime location, and we're going to basically phrase this as an entity recognition problem. And we're going to train something like a sort of standard entity recognition model that's going to read the text and try to apply begin, inside, end labels to these words. So this coding clearly can meet the business need. So it's clear that if a classifier could reproduce these annotations accurately, we can use the annotations that it's producing to meet what we need. The question is this the best way to frame the problem so that it will be cheap to acquire the annotations and that the model will perform accurately? And I suggest that actually it's probably not. So here's an alternate way to think about this instead. So instead of having this sort of annotation, we might instead do something like this. So we might apply a bit of information across a wider span of text. So we do text classification for crime, and then we might have a more generic person, location, etc. Tagging. And this doesn't necessarily tag exactly the same information. So here, for instance, King's Cross is tagged as a location, as well as East London, because we're not joining in the coding of the roles that we have here. Like, we're not trying to figure out that East London was the location of the crime. At this phase of it, we're just tagging as a location. So the thing to think about here is that we're really making the problem a lot simpler for each of the models that we're composing together. So it's a lot simpler to have one text classification model that tries to decide whether a crime is being discussed than to replicate that information across and kind of adjoin it into the entity classifications. And so instead of trying to decide at each of these things that, okay, is this a crime location as well as whether it's a crime, we can factor the information away from each other. And that is going to make the annotations a lot easier to both annotate and for a model to recognize. And it'll likely take much less annotation to do this if you compose it this way. So there's still extra logic that has to be performed to, say, figure out that this person is actually the victim of the crime as opposed to a perpetrator or some incidental person. But we can do this with other annotations and other rule-based processes as well. So here's a quick look at some of the annotations that spaCy produces that are not problem-dependent. So these are sort of generic information that's added as well. So here we can see that Alex Smith is annotated as a passive subject of stabbed. In other words, he's the person who was stabbed, and that grammatical relation there is linked there. So we could have an extra sort of process that says, okay, something like stab, and we can build up a lexicon of these sort of victim words, and we can then have a rule-based process that says, okay, if we've got that sort of crime act, and then you take the subject of it, that's going to be the victim of the crime. Now, I don't want to commit to one specific plan for these things because the point is that it does have to be experimental, but I hope you can see that there's a lot of choices here, and making the correct choices on all of these things is not trivial. So the correct answer is not to decide everything up front, assume we're right, and start collecting lots of annotations. We need to start iterating and start seeing what works for any specific problem. And that's going to, in general, yield much better results if we take this sort of iterative approach. So as I said here, the sort of take-home message here is that we often want to be composing generic models into novel solutions. So we can have generic categories like location and person, and this lets you use pre-trained models like spaCy provides, and then fine-tuning those pre-trained models on your domain is a lot cheaper than creating annotation data for new categories. And in particular, you don't have this risk of making new categories that then you have to refine later and then you have to throw out all of the data that you annotated before. So life's a lot simpler if you can rely on generic categories much more than trying to come up with your own. And then additionally, if you have things like events or topics and things, like this sort of semantic information, I suggest that you usually think about annotating this at a sentence or paragraph or document level rather than trying to affix it to specific phrases. And the reason is that if you do this as phrase annotations, you very often have indeterminacies about the boundaries of these things. And especially if the language gets even slightly metaphorical, trying to figure out exactly which word in a sentence encodes that a crime was committed ends up being super hard. So if you want it to be something like, okay, I just want to know, is it about a crime? You really shouldn't try to put that at the word level. You should put it at the sentence or paragraph level. And then if you do that, the annotation's easier, the classification's more consistent and easier to learn, and then you can combine these pieces of information to produce the solutions that you're interested in. Similarly, if you want something that are sort of like semantic roles, or like the person who did something versus the person who didn't, you can annotate those things by single words and then use the syntactic parse to get the boundaries around that. So you're basically sort of like having a grid that you're snapping the phrases to, and this makes sure that your boundaries always make sense. Okay. So here's a quick look at how this ends up looking, or how this sort of workflow looks if you're using our tool set. So the Prodigy annotation tool gives you a few commands that you can basically use to start a little web service locally, and you give it a name of a data set, and it's going to save that in a little a database locally. By default, we use SQLite to sort of save you from installing extra software. And then you can give it an input data file, which is by default just formatted in JSON-L. It can also read from standard input, and you give it a label that you might want to annotate. So in this case, you're going to get this feed of data, and you can just basically click through whether it's a crime or not. And so this is super quick. because you're just annotating these short pieces of text like a sentence and applying a binary label. So it's pretty normal to be making one of these decisions every 5 to 10 seconds or so, because you basically have this really simple decision to make. And that means that you can annotate the data set for that very quickly, and you can build up just enough records to see how accurate that model will be and how simple the task will be very quickly, like less than an hour of work, and you can have an initial result. Similarly, we have this teach recipe that lets you improve the accuracy of pre-trained categories. So, you can feed in a label like person or location, and if there's an initial model that can make those decisions, like for instance spaCy provides, you can just use this to sort of fine-tune the accuracy. So you can tell it whether the model's right or wrong, and it will train from that and basically update its accuracy on this. Then, as a next process, given all of the annotations that you've provided so far, you can run batch training and basically see how the accuracy does and try out different hyperparameters, and you can do this for the NER as well. And then the output of all of this is essentially just a model that you can feed into spaCy. So the spaCy NLP library lets you just load this up, and then you just get basically this function that converts text into this doc object, and the doc object that makes the annotations easy to access. So you can do doc.ents, and assuming everything was correct, you'll get something like Alex Smith or East London, and these will have the labels that you are interested in attached. So Alex Smith hopefully will be labeled as a person, East London hopefully will be labeled as a location, and then you also get this, there's a text categorization, so that's accessible at doc.cats, and that will tell you that it was a crime with 90% certainty or something like that. So the whole workflow here is pretty simple, and importantly, it's very useful to make sure that it's outputting a model in the form that you can then easily plug forward into your production system, so that you can start trying this out in the context of your application and sort of both sanity check it and start seeing what would be useful and what isn't. So you basically try to avoid spending too long in the single sandbox or too long in any one step of that iterative process. If we can iterate over the whole, all of the steps quicker, then we can sort of loop back around and sort of progressively improve it. So rather than spending, investing huge amounts in an annotation project or design project, you start getting evidence quicker. And, it's really follows the same sort of logic as other development things, where the waterfall methodology tends to perform worse if there's uncertainty than having a sort of rapid iterative approach. So, and that really feeds into this second problem that I'm basically going to highlight here, and that's that if you really only have an annotation process that's designed for big annotation projects, and you're only thinking about how to scale up and how to collect tons of data because you assume that that's what you need, then your time to first bit of evidence is going to be very large, and the investment that you need to start collecting some bit of evidence is going to be very high. And that's going to be a real problem, because you're going to design this whole big annotation process around assumptions which later may be unideal. So instead of this, we want a much more fine-grained approach where you can scale down and get a much... and you can start basing your assumptions on contact with data and evidence. So we want an easy way to get, say, 200 annotations so that you can run an easy process. We want a process where you can have, say, do 1 hour of work and get a meaningful insight into what you should do next, and in order to schedule the next 5 hours of work so that you can schedule the next 20 hours of work, etc. And you can always be sort of bootstrapping that forward based on contact with the data and evidence instead of just guesses about what might work. And this is good because of that fundamental uncertainty that we have around this. So if you just make guesses, you're very likely to be wrong. And that's why having a process that scales down as well as a process that scales up is so important. And so, the prescription that we have here is that, basically even as a data scientist yourself, your job isn't just to, flow your tensors and design models. You should be doing these annotation projects initially yourself. And that is going to give you a much better insight into what's likely to work. So as part of your sort of daily workflow, having tooling that makes it easy to start annotating data to evaluate your ideas, and to start, if you have a new idea about, this product might, a new machine learning powered feature might work in this product or business process, instead of sort of collaring management and putting everybody in a room to schedule a meeting to barrack for your case, you can just start trying it out, and you can start seeing whether you're right that some approach is tractable, that some model will work. And this is going to be ultimately much more productive, even though it feels like, we're wasting time I'm annotating, it's much more productive than having an idea for, widening your hidden layers and coding that up and then waiting for that to train, etc. The real good leverage point is going to be in the way that you design the way that you break down the problem into different machine learning models. And so if you spend much longer, basically figuring out that you're annotating the correct things and structuring the project correctly, you're going to have a much better chance of success. A final tip that I would recommend is this sort of A/B evaluation. And so this is really a trick that lets you do fine-grained evaluation without a huge evaluation set. 10, 20? 10, okay, cool. So what I mean by this is normally if you're, let's say you're interested in figuring out whether some model is 90% accurate or 91% accurate. Well, in order to sort of figure out that 1% of accuracy, you probably need to base that decision on about 10 examples. So you need about 1,000 annotated examples to sort of reliably guess that 1% sensitivity. Well, if instead of that we do A/B evaluation, we can actually do that much easier. So this is what the A/B evaluation tool looks like in Prodigy, and actually it's especially good for generative outputs where having a fixed evaluation set is not even very tractable. So imagine that we have an image captioning problem, and so we have this image, and we want to know which of these two outputs is better. So imagine that we've got two models that we're trying to evaluate and compare, and so one of them has told us that this is a pug in a blanket on the grass, and the other one has told us that it's an unhappy child in the garden. So clearly we want to say that this one's better. And so if we randomly shuffle the order of our system outputs, we can basically just, A/B evaluate this and click through a few hundred times. And we can do that very quickly. And this means that even if the models are only slightly different, if they're outputting the same thing, we get to skip the example. And so you're very directly saying, this one or that one is better. And that means that even if you're only making a small tweak, you can probably evaluate it yourself in about 10 or 20 minutes. You don't need a huge evaluation set to do this. Now, of course, this isn't as repeatable as a huge evaluation set, and so eventually you do want a sort of stable, consistent evaluation. But when you're scaling down and you just want to, basically be more nimble, the A/B evaluation is a good approach for a lot of things. And again, it gives you a good evaluation even on generative outputs instead of relying on some nonsense like a blur score or something. Okay, so then a final problem that I want to highlight is that even the way that people actually approach annotation is often pretty bad. And we summarize this problem by saying that it's hard to get good data by boring the shit out of underpaid people. So if you just put your task onto Amazon Mechanical Turk, there's a whole lot of intermediate problems that you have to solve to actually make sure that you're going to get quality annotations that you can learn from. And if you don't immediately get quality annotations that you can learn from, it's very hard to interpret the results and inspect whether the data was wrong or your model is wrong or the annotation scheme was wrong, because there's too many explanations for the problem. So I would suggest that processes like Mechanical Turk or other outsourcing-based processes that are designed to drive the marginal cost of new annotation towards zero are actually mostly solving the wrong problem. What you want is a time to first data set and a process that's going to be reliable, rather than trying to see it as, okay, how much can we pay per individual annotation? The overhead is actually something that matters a lot more. And so I actually think that for most situations, having a small annotation team working consistently with a good workflow and good communication with data scientists is usually going to give you better results. And in particular, reframing your problems so that you're breaking them down into smaller pieces, so that the annotator has to consider less at a time, is also very productive. So the insight here is that the annotators don't need to have a workflow that exactly matches the way that the model works. So even if the annotators are sort of seeing a sort of pre-suggested output or pre-filled output and the model won't, that's probably going to be fine. And in fact, it often makes the annotation more accurate to have it semi-automatic. Because if you try to have somebody constantly make the same decision 1,000 times in a row, it's very likely that they're going to have some reliability errors, and they're going to have make some errors that a machine never would. So for instance, if you're tagging parts of speech, you pretty much don't want to have a human annotate every instance of the as mark that as a determiner, because they're going to be wrong sometimes, and when they're wrong, they're probably going to really confuse the model. Whereas if you do that semi-automatically and they only have to basically correct this when it's wrong, you're going to have actually more consistent annotations. Finally, I also actually suggest that doing annotation in-house and having is good for lots of reasons, and not least of which is data privacy, because you don't have this sort of third-party provider problem who probably wants to be clever and outsource the data themselves. And so then the text, which maybe say user feedback on your product, or text that was uploaded into your platform, or user messages and things, might be getting out to some arbitrary number of people, which even before sensible regulations were introduced, I actually think is something that people should definitely worry about, and is not a good look for anybody. So to wrap this up, the solution to this chicken and egg problem is iteration. So, and this sort of makes deep sense, right? Like, if you can't solve the problem analytically, we have to solve it iteratively. Like, if we can't reason from, if we've got this sort of circular dependency and we want to sort of progressively estimate all of these things, well, we have to just start, make an initial estimate and start feeding that forward, and then progressively iterate on this. And, in the same way that we would do this basically in a machine learning solution, I think the same actually works here. It's, a fundamental thing about the knowledge being float around, and the fact that there's this sort of dependency structure means that actually this is a, satisfying approach. So, thanks.
Thanks very much, Matt, for a very nice talk. Are there any questions in the audience over here? Would you like to moderate the questions yourself?
Sure.
Thanks for your talk. I just have one question about the screenshot that you displayed there about spaCy.
Mm-hmm.
It's able to detect the text as crime. Is it come automatically from spaCy, or you make some adjustment on it? So you maybe fit the label on it.
Okay, so I'll just go back to the slide just so that we have a grounding of what we're talking about. The process here of this batch train, that's outputting a text classification model that can then sort of feed into the spaCy pipeline. And so that sits in the spaCy pipeline, and it has the job of taking doc objects and attaching, making predictions based on its neural network model, and attaching those predictions into the doc.cats process. So you can actually, you could, for instance, write an arbitrary function that had that job and add it to the pipeline, or you could write your own machine learning model. But the built-in text categorization system that spaCy provides uses an ensemble of a convolutional neural network and a bag of words model, and then Prodigy trains this, and it outputs it into the model for spaCy to use.
So I think the label is in your data set. Right?
So the label crime comes in here, where we label this, and we do this text cat teach that creates the training data. Then in this step, we train from the training data, outputting a model. We use that model as the input into this NER batch train process, and that carries forward the text cat model into the full model that's output here, and then we load the full model, and that's how the data flows around. Okay, yes, in the back. Yes, certainly.
Okay. Yeah. You said somehow like you made the example to somehow like extract the victim and maybe also the murderer of a crime,
Mm-hmm.
and for that you said maybe use the dependency parser, but the dependency parser tends to somehow get considerably worse if somehow like your corpus has a different structure than the dependency parser was originally trained on. So normally dependency parser has an accuracy of 93% or something like that. But I see often that it gets down to something like 60% on some like very different colloquial speech. So how would you treat a problem like that?
So this is definitely a concern, and in particular, I would say that it's often hard to reason about or hard to guess how useful the dependency parse will be before you start trying things out. So if it is the case that you'd like to use this and the accuracy isn't high enough, having this sort of training process where you are basically improving the accuracy of it on your domain is something that we definitely see as a solution going forward. So the dependency sort of recipes in Prodigy are still a little bit in beta form, but you can already use this to start making some corrections to the dependency parser. If it is the case that the dependency parser doesn't do what you want, then actually having another model that is basically only constrained to work on the person category, I would say is probably going to be a better approach. So in other words, you could classify only the person entities and apply some sort of more specific model based on that for whether it is a victim. Another option would be that you might have a sort of fixed number of frames that basically predicate argument structures for shapes at which there's sort of these relationships between victim, perpetrator, etc. And if that's the case, then you can classify this, you can tag the sentence with those things instead of relying on the dependency parser's features. Finally, you can also reduce the sentence and train your own sort of little parse tree over just the input pieces which are useful. So you basically just use the tree building technology and train that yourself. And because that's working on such a reduced problem level and you can abstract the English so much, that may also be easy to try. May also be easy to train. So there's a sort of range of options that you can sort of think about and explore that will depend on the specifics of the problem. But I would definitely say that it's not something where you just know ahead of time that this is the one way to do it, let's invest everything in this. You should explore these things and iterate. Yes? Sure.
Hi. So you mentioned a dependency parser recipe. Do you see a more generic, just link prediction recipe in the future?
So you can definitely use the tooling there for sort of more generic link annotations. The only sort of coupling with the recipe there is that we wanted to have the pre-trained model there and have that sort of suggesting the links and things. So because the pre-trained models that we provide do basically this syntactic structure, there's a question of how you would sort of get the initial suggestions if you're doing it that way. But if you have some process that basically suggests links for you, you can certainly just pipe those into Prodigy and say yes or no to them. That's no problem.
We have time for one last question. Over there, I think there was first. Sorry.
Yep.
So I have a question in terms of the features that currently you guys are looking at, which is very focused on the text. Is there any focus towards other types of features that may be in the either visual or positional or formatting sense when processing things like documents or images with text? Are you guys looking to also use spaCy or one of these frameworks to be able to extract these features and load them and be able to analyze them even with Prodigy, like PDFs, etc.? Yeah.
So this has come up a bit over the last few months, and so it's definitely something that we've been thinking about. I think this the solution that I think is probably best is that you feed the output of, say, a more text-focused model forward as features into a downstream model which combines information from different sources. So, as an example of the type of thing which is coming up, people might want to do named entity recognition. There's some metadata attached to the article or something, like, maybe topic categories or something like this, and they want to use those features to improve the accuracy of the entity recognition, which is, a very reasonable thing to want to do. So rather than having a general purpose way of putting those features into the entity recognition model and kind of trying to retrain with new features, I think it's actually better to do it sort of the inverse and take the output of the entity recognition model and feed that forward into a next level model. And I think that'll make it easier for us to, be providing something which is reusable across different things, and also that you can sort of really write arbitrary features yourself rather than having to be limited to whatever feature API we ended up trying to expose to make a compromise for that. So I think that that's probably the best way to make that happen.
Okay. Let's thank our speaker again.